plasma machine, plasma cleaner, combined with the RIE electrode inside the chamber. So you can run both process, etching for samples and also cleaning. Etching, as you already know, you are making the process with etching gases. We will not make an example here because we have no etching gas here connected to the system.
We will talk oxygen.
Oxygen, the same process for cleaning is the same like the RIE. Just the gas is the variant here, and the power of the generator that you apply. Okay? Everything's clear.
We basically now have only oxygen, so we can use oxygen for plasma cleaning and RIE, and we have another outlet that we can later on put a different gas.
Yes.
In addition.
So this is the plasma. This is the chamber. Okay. This is the electrode. Okay. This is the electrode down there.
You know that in RIE you apply bias, so you need that. This is why I call it an electrode.
This electrode making also the RIE and the plasma cleaning. Okay. Our recommendation is to keep the chamber under vacuum when the system is not under use. Okay. So I will explain how to do this. That way you can keep the chamber clean and not so the inside the chamber will not absorb moisture and become dirty. So we are I think I already explained everything, and we can start. You are running the machine with this button. The pump under the table connected directly to the system, so it can be controlled from the system itself.
Just make sure it's on, and
you don't
are on.
Yeah, you don't have to. You are touching nothing except this machine. Okay, the pump is always on. Okay, so we got the main screen, and how it's built, and I will explain how it's built right now. So we have two kind of operation that we can do. One is automatic mode, the second one is manual. Here is the automatic and this is the manual. Okay? I will explain about automatic right now. In automatic mode you need to make to prepare a program right here. You are making a program, and you can choose the parameters of the process itself, like pumping down, gas supply, how you want to make the venting, plasma, everything. You can set all the variants right here. Okay?
And then you save it.
And then you save, of course, you save the program. Then the system remember the program even when you are shut it down and then turn off. It remembers the program, and you can do the same process. Okay, this will promise you repeatability to your process. Also, if you have multiple process that you want to run in this machine, you can program several programs here, and the system will save it. Okay.
There is a limit of number, or
I don't really know. Maybe
there is enough. Okay. 9.
Maybe 10. More. 10, 11.
Okay. It's more than enough.
It's more than enough, of course. So let's talk about the manual, and then we go back to automatic mode. Manual, as it sounds, you are making one-time process. Of course, you need to set all the parameters of the process here, and then you run it. How we are doing this? So first parameter is generator power. Okay, you need to choose the power of the generator right here. This is the set power in percentage. Okay, so this machine, if I remember well, the power of the generator is 200 watt. So 15% will be 100 watt. Okay, so let's arrange it somewhere. If we are intending to make cleaning I believe that somewhere around 80, maybe 70, 90 will be good enough. So we'll arrange it somewhere around 30, maybe 27. It's not really critical right now. We can adjust it right here. Let's say, for example, 30. Okay? And then you are pushing back. We set the power of the generator to 30. Okay? Next one is pressure. What is the pressure that you want to run the process? I believe somewhere around maybe 0.3 bar, 0.3 millibar will be good enough. Of course, it depends on your process and on your samples and the geometric of the sample, the dimensions, everything. So you need to make several processes, maybe more than several, to achieve the right result to your material. Okay? So this is the pressure of the process.
The maximum is probably 3 bar, right? Because this is the maximum.
Yeah, of course. But you are not running the process under 3 bar. Never.
Okay.
Never.
What is the maximum?
Most of the process run under between 0.2 to 0.6, somewhere like this.
Okay.
Yeah. Okay. So here we have the current pressure of the system. Okay. One more thing, the gauge inside the system can't read higher pressure. It's Pirani gauge. It can't read high pressure. So the pressure here will start fall after maybe few seconds. You will see this fall. Okay. So anyway, when I will open this valve of the pump and I will start pumping the chamber, you don't supposed to see this pressure comes down. Okay, at the first 2 seconds, something like this. Any questions? The next parameter, of course, is the gas supply. We connected the oxygen gas to gas line 1, so MFC line 1 will be our gas line right now. You are setting the gas flow with SCCM. I don't know, maybe something around 2 SCCM will be good. 2 SCCM will be good to clean. Here you have the gas type, oxygen. Okay. Everything okay?
Is it important that you give the name of the gas, or?
It's much more comfortable and user friendly, because when you have a new guy comes to the lab, if you see here argon,
but you defined it now.
Yeah, of course, if you will not write here oxygen, it's still oxygen. Yeah.
Okay.
This is the gas supply. Of course, we can read all the parameters that we set right here. And the CV, I didn't talk about it, it's current value. Okay? So of course now current value is above 9.99 millibar, and now the current value is 0. Yeah. MFC2 is not relevant for now, but bear in mind that you can set a flow for MFC2 if you want to run a combined cleaning with argon and oxygen, which is very common for cleaning. Okay, you can combine it. And the last thing is venting. When you are doing all this process, you understand that we are under vacuum, so you won't be able to open the chamber. Right now I can open the chamber because we are in atmospheric pressure, but as I said before, you are under vacuum during the process and after you finish it. So you need to vent the chamber in order to open the door. Everything clear? Okay. Here is the pump, the pump, how it's called, indicator. It's as you can see, it's working, but it is not pumping the system itself, the chamber. Yeah, because here we have a valve, edge valve. Okay. Okay, so we will start the process. I will open the edge valve. Now the chamber is becoming pumping. As you see, the current value is not atmospheric value, but in several seconds you will see the pressure force. As I said, the running gauge inside here can't read higher pressures. So in a couple of seconds we'll see this. First pumping need to be before you are flowing the gas. Very recommend to become something around to let the pressure fall something around 0.1 millibar. Okay, to be clean from other air or other gases. Any questions for now? Oh. One more thing that I forgot to mention, the pressure, I want it to be 0.1 back. Okay.
What is the highest vacuum that you can get?
Here, with this pump? Less than 0.1.
Okay, this is more or less the limit.
We achieved to get a lower pressure for 0.02, yeah, 0.02, but with a bigger pumping speed. Okay, this is good enough. Okay, we can run the process. Any questions? Okay, so now I need to.
Did you open the תחת את זה של החמצן? את ה...
ברז.
הוא סגור.
You just open the
the valve there. Yeah,
oxygen valve.
You don't need to touch the valve. It always open.
Okay.
Okay. Here, how I bring the X to play.
Maybe you touch the chamber?
Yeah. Start. Yeah. I forgot.
Okay.
Yeah. So. Oh, why not? Maybe one of the parameters I didn't set right. 0. I don't have current value. Why I don't?
Because the valve was closed, maybe. But,
maybe with
right?
we have enough pressure.
אפשר אולי